Posts on X yesterday, I think, are pivotal for the future of Tesla, the future of AI, and the future of robotics. One post is Elon Musk saying that with a 10x compute, you double the intelligence. I'm going to talk about this, actually a really profound statement. And second, one of the ex-employees or Optimus employees, I'm not sure, posted that in order to solve robotics, we need video generation capability so the robots can learn in simulation. Both of these statements are profound. I'm going to explain why, what it means for robotics, for AI, and for wealth creation. This is not even a podcast. It's September 11, 2025. This is Krimdelko. For the day, the fund is up roughly 5%. The market is up 0.5%. For the year, we are down 1.5%. The market is up 11%, but underperforming by 12.5%. So just jump right into it. So the first statement, which is if we increase compute by 10x, we can double intelligence. Now, that statement, first, it's a quantifiable statement, so that requires a quantifiability for compute and a quantifiability for intelligence. The first one is relatively straightforward. The second one, I think, is a little bit more involved, but I think it's very profound, because if we have something to measure, then we can also gradually improve it. This is absolutely fundamental. Marcus Hutter, in his book, Artificial General Intelligence, talks about this. I think Marcus is one of, if not the most underrated scientist in the AI community right now. I mean, he does work for DeepMind. He works with David Silver, who has a huge reputation because of AlphaGo Zero. But nevertheless, I think if I walked around campus or Berkeley, I think his name is not going to be on top of people's heads. It should be, because he has made a huge effort in the last, decade and a half to fundamentally, formally define intelligence, define what it actually means to work on intelligence, and also explain some of the fundamental mathematical and statistical concepts, such as Solomon of induction, Kolmogorov, and complexity, that are underlying the idea of modern AI. He's also, in my opinion, the computational and algorithmic backbone of the bitter lesson, which is really the fundamental idea of where AI is going. Bitter lesson, the essay by Richard Sutton. Now, I'm at risk here of broadening my topics so wide that almost every sentence now should be an academic paper, and I don't want to do this. This is a podcast. The purpose of this podcast is to give people a sense of what it feels like to run a hedge fund. So this is not an academic podcast, and certainly not an attempt to explain a book of maybe 1,000 pages within 10 minutes of podcasting. So what I'm going to do is go straight right to the point. Like, we have a quantifiable measure of intelligence. It is related to Kolmogorov complexity. What it means intuitively is that an algorithm that is able to predict the next bit in a sequence of bits is the underlying mechanism by which we can then plan our next action, and therefore that is in essence what intelligence is, and the ability to predict the next bit and then plan based on that in order to pursue a certain goal. That's roughly what it is. The key is, though, that the algorithm that is the shortest bit string that can predict the next bit is more intelligent than an algorithm that requires more bits. This is might sound obvious, but it's really a profound statement, because it means that if we can explain something in a shorter version, then that is more valuable than the same explanation with the same result in a longer version. It also has fundamental mathematical consequences. For example, a shorter bit string, a shorter algorithm, a shorter an Occam's razor abiding shorter explanation of a certain mechanism is less prone to mistakes, therefore has more value. Now, the idea is we need to be able to predict the next bit, which is in essence predict the next state, in order to plan and in order to conduct reinforcement learning, which is the fundamental idea of adaptive agents, the fundamental algorithm for adaptive agents. So that's the quantitative approach towards intelligence. So we have a number. We literally have a number that can be increased, and therefore that can help us um, gauge whether we get better in terms of intelligence. The ultimate goal is to pursue goals. That's the goal. So we have intelligence, we have we have an algorithm that can predict the next bit in a stream of bits that can be used for planning, and the planning is supposed to increase the reward relative to a goal. So what we need to teach our agents is how to pursue goals. We don't teach them tasks, we teach them how to pursue goals. That's the fundamental idea. So this goes back to the bitter lesson and Richard Sutton's seminal essay about that. If we can do this, if we can actually formulate intelligence in this way, then we are compute constrained, and that's the only constraint that we really have in terms of intelligence. So it's not about data or data labeling or better algorithms. It is we obviously have to find algorithms that abide to that concept, that follow the concept of the bitter lesson. But once we have it, we are only compute constrained. And the idea is here also that we don't have priors, or as little priors as possible, and we let the data speak for itself. I spoke about this yesterday in Jack Barker-Holder's PhD thesis. So what I want to talk about today is this particular post on X by Musk. He said that if we increase compute by 10x, we double intelligence. So that requires the ability to quantify intelligence. We quantify intelligence by the means of Kolmogorov complexity and the ability to predict bits and then use that for planning to pursue goals. So the fundamental idea behind any of these things is to be able to pursue goals. Now, how we actually get from pursuing goals to monetization and wealth creation, that's for another podcast. But let's just assume that, or let's just put as a postulate here, that if we can increase the ability to pursue goals, if we increase the techniques and the abilities to pursue goals, then we can monetize and create wealth. Now, the actual statement is pretty powerful. It's akin to Moore's law, right? We increase compute by 10x, we double intelligence. I would say it takes the community roughly 2 years to increase compute by 10x. What I mean with that is available compute. So that's not just, transistors, that is, number representation, that is Moore's law, that is connectivity, that is, less precision, quantization, and the latest version now also maybe optical interconnect, so we can have actually much more memory. So all of these things together yield towards what I call Jensen's law, which is that we increase, probably we can do every 2 years, we can 10x the available compute for AI. And if that's the case, then we have basically a 2-2. So we have 2 years 10x compute, 2 years double intelligence. So every 2 years we double intelligence. So now every 2 years now, from now on, we will increase the ability to pursue goals by 100% based on the form of intelligence that is roughly like, let's say, Marcus Hitter's definition of intelligence. We can argue about which definition of intelligence we want to use, but what's important here is that there's a quantifiable quantity of intelligence. That's key, because that way we can measure what we're actually doing. So that's the first post, I think, incredibly powerful and something that we should be working on going forward. The second post, almost as important, is that came from I think it's an Optimus employee. And the statement here is that if we, robotics, like Optimus will be solved only, or a general robot can only exist in the context of video generation. So we're going to have to solve video generation. So basically what we're going to have to do is solve exactly what Jack Barker-Holder is trying to do in his PhD thesis and later on with Genie, something like that. So we have to be able to create artificial worlds, simulate the worlds in which robots can learn, because we just don't have the time and the money and the resources to roll out all the possible interactions that a robot needs to go through in order to actually be able to act in the real world and deal with all the edge cases. So we need to find algorithms that can create worlds from data. So unsupervised environment design, and then we need to create world models, learn from world models, and use reinforcement learning, auto reinforcement learning. So we not just do we need to have a flexible agent that adapts to the environment, we need to have adaptive environments, and that has to happen in simulation. So these are the two quotes that I wanted to talk about. I think we're getting a lot of questions from our investors about, is this a bubble? How far can this go? And we keep saying the same thing. We almost sound like a broken record at this point. And the message is there is unbelievable upside here because we're on the cusp of an industrial revolution that will put all the other industrial revolutions that we had in a shadow. And that's because once intelligence is only compute constrained, once intelligence is energy constrained, which is really what it's going to be, then we will have massive wealth creation, and therefore also the ability to create wealth for ourselves. And that's based on the Peter Thiel argument, P times Q, so the amount of wealth you create for society, P times Q, which is the amount of wealth you actually keep for yourself. That is roughly what you can expect. So the higher the wealth you create for society, the more you can keep for yourself. We believe that this ratio should be about 10x for people to tolerate wealth creation. In other words, if you don't create at least 10 times more wealth for society than you create for yourself, well, I mean, that's company-wise, of course, then you won't be tolerated by society. So that's kind of the way we see the world, and these two tweets, very pivotal. And I think we are on the cusp of a massive wave of investment, capex, and wealth creation in AI based on the continuation of the bitter lesson, based on the idea that we will very soon transition into the real world and actually solve some real fundamental problems for society in the real world, better materials, better labor situations, more quality in actual physical goods, and eventually maybe even on healthcare. But of course, we here are very skeptical of healthcare. But fundamentally, still, even with the sectors that will be affected by AI, the real sectors, even that is going to create massive upside in GDP growth and wealth creation. Thank you.